The biggest volcanic eruption of the past 2 million years.
Would have been the mother of all explosions.
75,000 years ago, the supervolcano Toba threw the planet into climatic chaos.
It was this huge climate effect that made it so devastating around the world, not just where the volcano erupted.
Temperatures across the planet dropped. The world entered into a volcanic winter, and the human race was pushed to the brink of extinction.
For a person living after this eruption, really only the strong would have survived.
Could one eruption have caused such apocalyptic destruction? And what will happen if and when this type of mega disaster happens again? (73,000 BC), Sumatra, Indonesia. A sleeping giant named Toba awakens from a 700,000-year slumber. It unleashes the most explosive volcanic eruption of the past 2 million years.
It would have been the mother of all explosions. People could hear it from thousands of kilometers away.
Toba was 40 times larger than the largest eruption in recorded history, and it probably had 40 times the impact, and that was disastrous.
3,000 times more powerful than Mount St. Helens, Toba sends volcanic debris flying through the air at speeds of up to 60 miles an hour. Everything within 500 miles is doomed.
It's a very violent, fast process. Anything in that area, any form of life, would have been annihilated.
The eruption continues for an entire week. Toba blasts 2,800 cubic kilometers of sizzling magma 30 miles into the atmosphere.
You know the Beltway around Washington, D.C., it's about 60 miles around. If we wanted to fill that up with all this rock and ash, it would make a disk a mile high covering the inside of the Beltway.
The ash spreads for more than 2,000 miles and buries everything in its path in up to 20 feet of debris.
The dust seems to have traveled about 2/3 of the way across the Indian Ocean to the west, and as far as almost to Taiwan on the east.
The ash begins to block the sun.
You were completely isolated from the sun. You didn't know whether the sun was up or not because there was this very thick cloud of ash in the atmosphere.
With a typical volcano like Mount St. Helens, the effects are felt locally. The initial eruption and the ash it releases are what caused the destruction. But Toba also releases something more deadly: massive amounts of invisible sulfur gases. These gases reach the uppermost layer of the atmosphere, which enables them to travel around the world, setting the stage for this one volcanic eruption to unleash a global catastrophe.
The amount of sulfur dioxide that comes out of the volcano is very important in terms of its impacts. If it's a relatively small amount, it's the kind of thing that the Earth system can deal with and absorb. But if it's a huge amount, then you're talking about major problems.
Major problems like instantaneous and drastic temperature changes.
These sulfur gases converted into particles. We call them sulfuric acid aerosols. And this cloud of particles was blown around the world by the wind and stayed there for several years, blocking out the sun and making it cold and dark at the Earth's surface.
The sulfate particles that are in the stratosphere act as a kind of a sunshade to reflect sunlight away from the Earth and cause cooling.
With the Earth's rays being deflected back to space, global temperatures plummet by as much as 25 degrees Fahrenheit. The entire planet spirals into perpetual winter.
It was this huge climate effect that made it so devastating around the world, not just where the volcano erupted.
Toba has unleashed a worldwide catastrophe, a phenomenon scientists call a volcanic winter.
A volcanic winter is you've got such extreme cooling, it goes throughout the entire year and can go on for several years or decades potentially.
Toba's volcanic winter will be more severe than a nuclear winter produced by 20,000 atomic weapons. The drop in temperature quickly turns lush rainforests into dry wastelands and arid deserts into frozen tundras.
You can imagine a place like Nairobi, snow and frosts throughout most of the year.
Vegetation, unable to adapt to the sudden shift, quickly dries up or freezes. Animals who can't find enough nourishment to sustain themselves perish. With the food chain crumbling, prehistoric humans who rely on hunting and gathering begin to die.
You're sort of living on the edge anyway. You don't have a way to store food. You don't have a supermarket when you run out of milk. You're working with your environment, and if the balance goes haywire and the normal food supplies disappear or die, then what do? You're in trouble.
At the time of Toba's eruption, there may have been as few as 1 million people inhabiting the planet in parts of Africa and Asia.
There were at least two kinds of people alive at the time of the Toba eruption. There were people who looked under the skin very much like everybody else alive today, and we call them anatomically modern humans. In Western Eurasia, they were people who we call Neanderthals.
But as the planet slips deeper into several years of volcanic winter and temperatures plummet, they begin to succumb to starvation and disease.
So there would have been generations of people who had lived in a relatively warm global climate for 50,000 years, suddenly plunged into an ice age in just a few years.
And the cataclysmic impact on human beings 75,000 years ago may have had a permanent effect on every human being today.
If you look at the genetic diversity of people, it's surprisingly small, which basically implies that at some point in the time, the population just crashed. Maybe our population, our species, nearly got wiped out by the eruption of Mount Toba.
The global storm set off by Toba may have crippled the planet and pushed humans to the brink of extinction. But how do we know that this apocalyptic event happened 75,000 years ago? Could a single volcanic eruption have unleashed a worldwide catastrophe that caused temperatures to plummet and early humans to be nearly wiped out? For thousands of years, all evidence of this ancient storm remained hidden. But in the early 1990s, a hint of this prehistoric mega-disaster would be unearthed at the very bottom of the ocean. While digging for sediment, scientists make an astounding discovery.
Scientists can reconstruct what the temperature of the ocean was like in the past amazingly well and with tremendous accuracy by looking at different kinds of sediments pulled out from the bottom of the ocean.
When scientists analyzed the ocean cores from about 75,000 years ago, they noticed something unusual. For some reason, ocean temperatures drop by 10 degrees Fahrenheit.
Generally speaking, the ocean's temperature will often be fairly steady over 100,000 years or more. But every once in a while, when the scientists look through these old core samples, they will see some indication of a very abrupt change. When that shows up, it's an important clue that something must have happened to change the amount of heat that was suddenly coming into the Earth's environment at that time.
A 10-degree drop is a sign of a huge impact on the world. But what could have caused such a big drop in ocean temperature?
In terms of natural disasters, there are only two that we know of that would have such a devastating effect. One is a supervolcanic eruption, and the other is an asteroid smashing into the Earth.
But there's no evidence that an asteroid crashed into the Earth 75,000 years ago. There's only one event that might fit the bill: the eruption of a supervolcano.
Supervolcanoes are characterized as volcanoes that erupt over 1,000 cubic kilometers of magma.
They're basically humongous eruptions. Anything that we've seen in historical times doesn't even compare. Vesuvius wiping out Pompeii in AD 79, nothing. Tambora erupting in 1815, nothing at all. Supervolcanoes can drive catastrophic climate change globally. These are a whole order of magnitude larger.
For tens of thousands of years at a time, the world's handful of supervolcanoes lies dormant. But beneath their seemingly peaceful exterior, they're building up a vast arsenal of deadly magma and gases. But where is the cataclysmic volcano that exploded 75,000 years ago in this apocalyptic eruption? On the island of Sumatra in Indonesia is Lake Toba. This lake is 60 miles long, 20 miles wide, and over a mile deep. It is so massive it can be seen from space. The lake, it turns out, is no ordinary body of water. It is the biggest volcanic crater in the world. Scientists discovered this lake's secret when they uncovered massive amounts of volcanic debris at the bottom of the lake and for miles around its shore.
There are several lines of evidence that tell us that Toba erupted 75,000 years ago in this cataclysmic eruption. The thick deposits of ignimbrite, pumice, and ash that are found for 20,000 square kilometers around Lake Toba.
Are the remnants Toba left behind enough to prove that it unleashed a volcanic winter that crippled the planet? And could this type of catastrophe happen today? As scientists search for clues, they start to piece together a picture of apocalyptic change and one of the largest storms the world has ever seen. "75,000 years ago on the Indonesian island of Sumatra, a supervolcano named Toba violently erupts.
Toba would have been such an enormous event, and that was the largest eruption of the last 2 million years.
With a supervolcano, you see the potential really to affect the entire world. And that's rare with natural disasters. Most of them affect a localized area. With the super eruption, it really can affect world weather.
Toba sets off a worldwide storm that will block out the sun, throw the global climate into chaos, and bring the human race to the brink of extinction.
The sun was just not warming the world. Within a few days to a few weeks, people would have started to feel the effects of the cold. The plants would have started dying, and then the animals and the people that feed off of those plants would have started dying as well.
But how could one eruption have had such an apocalyptic impact on the entire planet? A supervolcano, it seems, carries the trigger for worldwide destruction.
A regular volcano is really a pipe of magma running up from the mantle. But with a supervolcano, you see this huge reservoir of magma sitting right below the crust that actually dimples the earth above it.
The pressure beneath the earth grows as the magma chamber fills. And when a supervolcano like Toba erupts, it doesn't just send magma through a single vertical vent like a normal volcano. It explodes in every direction, sending destructive gases into the uppermost layers of the atmosphere. In its wake, Toba leaves behind a unique footprint, a gigantic volcanic crater called a caldera.
Toba collapsed and formed this huge hole in the ground that is there. It wasn't there before because all that stuff is now in the atmosphere.
But what kind of evidence could the supervolcano have left behind? Scientists need to determine just how destructive all of the ash and gas would have been on the planet. In the early 1990s, sediment from 75,000 years ago reveals that there is a dramatic drop in ocean temperatures. But if this is a sign of a catastrophic event, where is the evidence on land? What happened to air temperatures? Scientists finally discover the clue they need more than 7,000 miles from Sumatra, buried deep within the ice sheets of Greenland.
Ice cores are important for studying how climate changes because they can give a record of what was happening in the atmosphere year by year. As the snow falls, it's basically collecting everything that's in the atmosphere at that time.
The ice cores are a virtual database of the weather on Earth. With each year that passes, a layer of ice forms. That layer preserves the annual climatic patterns.
When you look at the individual years available in the ice core, very similar to a tree ring. You can count each year because there are different characteristics that happen.
It gives a very detailed record of the climate of the last 125,000 years. Over 2 miles of ice has accumulated in that time. And so it's justifiably called the 2-mile time machine.
Could evidence of this global disaster be locked within these ice sheets? When climatologist Greg Zielinski and his team begin to analyze the ice cores from 75,000 years ago, they find some astonishing data, something that they've never seen before.
We found that there was this very, very large increase in the sulfate.
Sulfate is a signature of volcanic eruptions. When volcanoes erupt, they emit sulfur gases along with ash and rock. Small sulfate peaks in the ice usually indicate a typical volcanic eruption somewhere in the world. But the sulfate levels Zielinski finds from 75,000 years ago are simply off the charts.
It was like 3 orders of magnitude greater than anything else we had seen. Really a fantastic discovery. We've never seen anything to have really perturbed the atmosphere to this extent.
Levels of sulfate this extreme can only mean one thing: a supervolcano.
We were very aware that back around 75,000 years ago was this huge Toba eruption, so our first thought was that could easily be the Toba eruption.
During a typical volcanic eruption, when sulfur is released into the air, it only has enough explosive energy behind it to make it into the lower layer of the atmosphere, called the troposphere. There it will form acid rain. But the effects of acid rain are localized and temporary, and the sulfuric acid falls out of the atmosphere in a matter of weeks. But if the volcano is massive enough, the sulfur gases will travel 15 miles into the uppermost layer of the atmosphere, called the stratosphere. There they will make their way around the globe and take on a whole new level of destruction. They can unleash a volcanic winter.
It's a really explosive volcano. That sulfur dioxide goes up into the stratosphere and it causes these sulfur particles that reflect the sun's heat away, and that causes cooling.
Scientists have seen the effects of this sulfur dioxide in recent history. In 1815, the eruption of Mount Tambora in Indonesia killed more than 10,000 people and caused a year-long volcanic winter that we now call the year without a summer.
The Mount Tambora eruption sent 400 million tons of sulfur dioxide into the atmosphere. In the next summer, in 1816, in June, snow fell in New England, harvest failed in America and Europe.
Agricultural production crashed. A bushel of wheat suddenly went through the roof and went up to $2.50, which wasn't reached again until 1972.
Hundreds of thousands of people died from starvation, and you saw an incipient outbreak of cholera actually widen into a world epidemic simply because of this one eruption.
The drastic climate change would make an impact on works of literature as well. Author Mary Shelley is so captivated by these sudden and extreme changes in climate, she produces her masterpiece, an iconic horror story, during the summer of 1816.
She wrote Frankenstein, inspired by the climatic effects of a volcanic eruption. At the beginning of the book, the monster is climbing over the ice. These cold, icy images were inspired by the weather outside. They didn't know it was caused by a volcanic eruption. They just knew how cold and gloomy that was.
But as devastating as Tambora's eruption is on the planet, it would have paled in comparison to the volcanic winter unleashed by Toba.
Tambora was probably at least 10 times smaller than Toba.
If an eruption the size of Tambora caused the year without a summer, then Toba could have easily caused the decade without a summer.
After Toba erupted and these aerosols were up there for 6 to maybe 15 years, during that time you certainly would have seen much cooler conditions on the Earth's surface.
A prolonged volcanic winter would have catastrophic effects on any ecosystem and could send the global climatic balance into chaos.
Potentially what could have happened following that is that you start cooling major parts of the Earth's surface, and especially the oceans, the sea surface temperatures.
As sea surface temperatures drop, ice begins to expand. And with the ice growth comes continually lower temperatures and drought. Suddenly, early humans are seeing temperatures plummet by as much as 25 degrees Fahrenheit.
25 degrees Fahrenheit, that means the whole world was below freezing.
Once that cooling starts taking place globally, you start to see the ice expand, both on the ocean and on land. And once you have that kind of cooling effect, could kick off a process that's a self-reinforcing cycle that could cause more cooling.
Could this storm have impacted the planet so severely that it permanently changed the global climate? Did the world's worst volcanic winter send the planet spiraling into an ice age?
The world wasn't ready for an ice age, but it was pushed into one.
When the supervolcano Toba erupts on the Indonesian island of Sumatra, it unleashes a worldwide catastrophe. The planet is plunged into several years of perpetual winter. Animals and humans are pushed to the edge of extinction.
The volcanic winter from Toba is the worst that we know of in the last 100,000 years.
It has huge implications for how you can survive. You can't put enough food resources away to survive. Very hard to plan for those sort of big events.
But after several years of volcanic winter, the debris and lethal gases released by Toba finally begin to fall out of the atmosphere. The sun once again returns to the horizon, but the frigid temperatures gripping the Earth do not retreat. In fact, geological records extracted from the ice cores in Greenland show that shortly after Toba's volcanic winter comes to a close, the world plunged into a new climatic state, a 1,000-year ice age.
Pretty soon after Toba, for the next 1,000 years, ice sheets began to build up over North America and over Europe. And so people have suggested maybe Toba caused an ice age because it occurred right when this ice advance took place.
Could the mega disaster triggered by Toba have unleashed a worldwide climate shift?
When global temperatures drop by just a few degrees Celsius, there can be quite a few effects around the planet. Glaciers that are retreating could advance instead.
An ice age is when the Earth's temperatures decrease for an extended period of time.
The global temperature is about 9 degrees Fahrenheit colder than normal.
This temperature change can result in the expansion of ice sheets over entire continents.
An ice age has the effect of capturing more and more water in big sheets of ice that then start to extend out as big glaciers and ice sheets across the land.
A destructive cycle takes over. As ice sheets expand and sea levels go down, sunlight is reflected back into space and temperatures continue to drop.
And what happens when you get an expansion of snow and ice is you make the Earth whiter and more reflective, so it reflects away more of the sun's heat, which will cause it to get even colder.
Could a single volcanic eruption have triggered an ice age?
The timing of the Toba eruption with the development of ice sheets on the continents seemed to coincide very well. At the time Toba erupted, it looks like we were starting to see the development of large ice sheets on the continents. And so that leads to the question that did Toba actually cause a glacial period?
Meteorologist Alan Robach has created computer models to measure the potential climate effects unleashed by volcanoes.
What we can do is we can use climate models. We can calculate how much the temperature would change. We use them to forecast the weather every day.
But there is no concrete weather data from 75,000 years ago. In order to simulate the impact of a volcanic winter like Toba's on the planet and determine whether it triggered an ice age, Robach has to draw upon the closest modern counterpart. The 1991 Mount Pinatubo eruption in the Philippines. The most destructive explosion of the last 100 years.
Pinatubo was the largest eruption of the 20th century in terms of the amount of sulfur it put in the atmosphere.
When Mount Pinatubo erupted, this sulfuric acid haze caused a significant decline in the amount of sunlight hitting the Earth, and it stopped global warming for a year.
Using modern satellite technology, scientists are able to gather data about the amount of sulfuric acid that Pinatubo releases into the atmosphere.
We can then go see how much ended up falling out in Greenland. We didn't have satellites when Toba. We know how much fell in Greenland because we have this has been preserved there for us. So we can just look at how much there is compared to Pinatubo. And it was about 100 to 300 times more than Pinatubo.
Knowing how much sulfur dioxide Pinatubo put into the atmosphere, and knowing that Toba is at least 100 times bigger than Pinatubo, Robach can use computer models to determine what may have happened 75,000 years ago.
So we will do something like put 100 times Pinatubo in, put 100 times the amount of sulfur that Pinatubo generated, and calculate the climate response and just see how cool it would get. This graph shows that it would get 15 degrees Celsius, almost 30 degrees Fahrenheit colder than normal for several years. So this would be a global winter and also a drought.
But did this extreme temperature drop, this volcanic winter, then cause an ice age to begin?
In order for it to form an ice age, it would have to cool the Earth for a long period of time. So we were trying to figure out how could Toba have caused the Earth to cool for a long period of time. No matter how much it puts in the atmosphere, it's still going to fall out because of gravity. We can get a volcanic winter, we can make it very cold and very hard to live for several years, up to 10 years, but then it gradually starts to warm up again.
What Robach's models reveal is that this cooling effect from Toba's sulfur gases could not have lasted forever. After Toba's volcanic winter, the planet should have warmed up, and temperatures should have returned to normal. But geological records show that the Earth stays cold for another 1,000 years. This leads Robach to believe that Toba erupts at a time when an ice age is already on its way.
It could have brought it on a little bit faster. We know that ice ages occur without volcanic eruptions. We know that this large eruption occurred just before an ice advance.
I believe what may have happened is that as the overall climate of the Earth was starting to shift into one of these 1,000-year periods of cooling, Toba erupted, and I think those volcanic aerosols helped to cool sea surface temperatures, and what it did, it looks like it may have really enhanced that initial couple hundred years of cooling.
Although Toba may not have been the trigger for a 1,000-year ice age, its aftermath could be responsible for something far more devastating, the near extinction of humanity. Could Toba have nearly wiped out all human beings on the planet? The clues to this global disaster may be found within the DNA of each living person today. The storm that ravages the planet after the eruption of the supervolcano Toba is unlike anything the world has ever seen. It sets off a volcanic winter that causes temperatures to plummet by as much as 25 degrees and cripples the food chain. Plants and animals struggle to adapt to the frigid conditions. But it's early humans who face the greatest threat of all, the threat of extinction.
Imagine you're sitting in front of your cave And all of a sudden, in the distance, the sky starts getting dark, and the sun gets blocked out, and it starts getting colder and colder, and you say, what have I done to annoy the gods? What's happening?
The people at this time really were suffering some serious climatic change, really cold conditions, unlike anything that they had experienced.
It doesn't take long for disease, famine, and death to set in.
For a person living after this eruption, really only the strong would have survived.
As this cooling occurred, you can imagine populations would start to crash. We're talking about generations being decimated.
From what scientists can tell, before the Toba eruption, a small but growing population of early humans inhabits Africa and possibly parts of Asia.
There were people who looked under the skin very much like everybody else alive today.
Their hunter-gatherer way of life means they depend on their local habitat and stable climate conditions to sustain themselves. But as the volcanic winter sets in and temperatures remain frighteningly low year after year, early humans struggle to survive.
So you have to imagine a landscape populated by small groups of hunter-gatherers living at low population densities. And when this disaster struck, people who were not in the best environments would have been unable to feed themselves.
The questions scientists have to answer so many thousands of years later are: how dramatic is the impact of this storm on these early humans? How many are able to survive? The answers, it seems, can be found inside all of us.
The geneticists have ways of analyzing the modern populations to reconstruct the past population sizes.
Today, scientists can determine every person's genetic heritage by mapping the human genome, which is made up of DNA.
There's a part of the DNA that only is transmitted from females to females. It's called mitochondrial DNA. So it's a perfect marker of inheritance.
By examining mitochondrial DNA, scientists are able to trace every single human being's genetics for thousands of years. And it tells an intriguing story. Despite millions of years of evolution, there is very little variation among the 6 billion people living on Earth today.
Humans are very unusual in the world in their genetic composition compared to most other species. People as far apart as the Eskimos and the Australian Aborigines and southern tip of Africa are genetically more similar to each other than 2 chimpanzees from the same social group in West Africa.
What could cause such limited genetic diversity? As scientists analyze modern human beings' genetic history, they find a sudden decrease in the population about 70,000 years ago.
There weren't very many different sources of these genes going back to that time period.
It had to have been a massive catastrophe to cause such widespread death. Could Toba be the culprit?
When the geneticists found out that there had been this huge environmental catastrophe at that time, then it made sense.
The volcanic winter and its consequences for global climate and food supply caused the human population to crash.
Anthropologist Stanley Ambrose has been studying the effects of Toba's aftermath on early human beings for more than a decade. He believes this prehistoric event caused such an abrupt drop in the human population, it changed the genetic destiny of humanity.
Before Toba, there may have been 1 million people alive in Africa.
But after Toba, scientists believe the entire human population crashed to as few as 30,000 people. In the aftermath of one storm, the world's population dropped from the number of people living in Detroit to the number of seats in Fenway Park.
Geneticists have reconstructed a population size of about 5,000 breeding-age females. Everybody alive on Earth today can trace themselves back to one of these breeding-age females.
This rapid decrease in population is what scientists call a genetic bottleneck.
A genetic bottleneck happens anytime something eliminates most members of a species so that any future generations are descended from a very small population. It's kind of like some sort of disaster happened and the only people left to repopulate the world were the ones in your neighborhood. As diverse as your neighborhood might be, it doesn't represent all the different kinds of traits that you would find. So certain kinds of genetic traits, maybe red hair, for example, would suddenly vanish from all subsequent generations.
The genes that you see today really came from a small group of original ancestors. And it's possible to tie this in to the Toba eruption, that if it killed a huge enough subset of human ancestors, that maybe it did just leave this small core of humans to survive and repopulate the Earth.
And human beings are not the only species who experience a bottleneck during this relentless disaster. The groups of animals struggling to survive also show signs of their own dramatic shift in population.
Chimpanzees in Africa, orangutans in Borneo seem to have gone through a population crash. Every tiger alive on Earth today can trace its maternal ancestry back to about 73,000 years ago. There's all kinds of things happening around the world at about this time that suggest that populations of many species underwent some dramatic changes.
It seems that the Toba eruption and its aftermath don't just throw the planet into climatic chaos. They very likely killed the majority of life on Earth.
These sort of super volcanoes are almost like the doomsday scenario. We nearly got snuffed out by a super volcano.
The geneticists have shown that everybody alive on Earth today has an ancestry in Africa of less than 70,000 years ago. Where are all our missing genes? Our genes are missing because the people who carried them died out, and all of the people alive on Earth come from a very small number of individuals that survived this disaster.
A single volcanic eruption changes the course of human history. But what would happen if a supervolcano the size of Toba erupted today? Would it trigger another volcanic winter? And would the modern world be able to survive? "75,000 years ago on the Indonesian island of Sumatra, the supervolcano Toba erupts, sending the entire planet into climatic chaos. It unleashes a volcanic winter that may have pushed the planet into a 1,000-year ice age and brought human beings to the brink of extinction. But could this type of mega disaster happen today? Is there another sleeping giant out there waiting to erupt and wreak havoc? And could our modern world and race survive?
You can't stop volcanoes. Disasters of that scale are beyond human control.
What could we do to prevent another volcanic winter? Well, nothing. I mean, you really can't. Nature has a way of doing what it wants, and really the humans just have to adapt to what nature throws at them.
Today, the site where Toba erupted is showing signs of increased volatility. Workers are keeping a watchful eye on the seismic activity in the area.
In the last million years, Toba has erupted 4 times. Could it erupt again? We believe there is magma still beneath Lake Toba. There are small volcanoes inside the Toba caldera, and there are hot springs in there.
For the time being, Toba does not seem to be an imminent threat. But elsewhere around the globe, supervolcanoes are growing. From Italy to Japan to New Zealand, they erupted in prehistoric times, and they will erupt again. When that happens, they will trigger disasters that could cripple modern society.
If an eruption the size of Toba erupted today or tomorrow anywhere in the world, there's nothing you can do. Most people would die. It's hard to imagine people that would survive. If you had a fallout shelter with 10 years worth of food and enough weapons to keep all the other hungry people out, you could probably live if you call that living.
What most people don't realize is that some of the largest supervolcanoes in the world are actually forming in our very own backyard.
There are regions in the western U.S. that have the potential for mega eruptions.
In California, the Long Valley caldera sits just next to Mammoth Mountain, a popular ski resort. When Long Valley erupted 750,000 years ago, its ash covered everything as far south as Texas and as far east as Nebraska. In northern New Mexico, the Valles caldera erupted more than 1 million years ago and devastated the land as far east as Iowa. But the most notable and active supervolcano is actually one of America's favorite family destinations, Yellowstone National Park in Wyoming. The entire park is a gigantic caldera with boiling magma pulsing just beneath visitors' feet.
The magma that forms the supervolcano in Yellowstone is actually what heats the geysers and the mud pools and the other natural formations you see.
Scientists believe that an eruption at Yellowstone and its aftermath would be comparable to Toba.
Well, the interesting aspect about Yellowstone is that when it erupts, it looks like it erupts big, real big.
Yellowstone has had 2 supervolcano eruptions in the past few million years.
In fact, it seems that Yellowstone is on a 600,000-year cycle. The last time Yellowstone erupted? 650,000 years ago. What would happen to modern society if one of these supervolcanoes in the western United States erupted?
If the same amount of ash from the Toba eruption were to, say, erupt from Yellowstone, that would cover the continental United States in about 4 inches of ash. Imagine the effects that that would have. It would just be horrible.
Just as with Toba, the area closest to the super eruption would face the most immediate devastation. Although Wyoming is a relatively rural state, there are urban centers like Las Vegas within striking distance.
If a supervolcano were to erupt in the western United States, the odds of surviving in Las Vegas would really be against you.
Massive amounts of ash would be only the first obstacle to overcome.
Las Vegas would be under inches of this really, really thick ash, and it's heavy. So it can collapse roofs, it can bury animals, it can bury people, it can bury cars.
As the ash spreads across the country, the air would be too toxic to breathe. People would be forced to wear protective masks over their eyes and mouths. Crops would fail, and water sources would become polluted. Car engines would clog, and any plane flying would come hurtling to the ground as the engines stopped working.
Jets can't handle that volcanic glass. It causes the engines to flame out, especially the bigger jets, 747s.
But the ashfall would be just the beginning. As we saw with Toba, while the ash settles, the destructive sulfur gases would be making their way into the stratosphere and circling the rest of the world.
It wouldn't just be a case of, oh, poor old America suffers, the world would suffer.
The devastation of a natural disaster like a hurricane or a tsunami or an earthquake can be dealt with because even though the people there are shocked, we can bring in food from other places in the world. We can bring in medical supplies. If a supervolcano erupted today, there wouldn't be anybody from any place else that would come help us, like in these smaller scale disasters. It would affect everybody in the world.
Scientists agree it's not a question of if another supervolcano will erupt. It's a question of when.
There's really no way to prepare for the eruption of a supervolcano. They're just so massive that this is not a power that we can contain with any known technology.
The Earth will survive. I'm not sure that humanity would bounce back from such a tragic kind of event, such a dramatic and catastrophic kind of event. So Earth, it turns out, is fairly resilient. It's the conditions for human life that may be more at risk.
Supervolcanoes do not just erupt, they are catalysts for global climate change and devastation. Unlike other natural disasters that are often localized and even avoidable, a natural disaster like the one unleashed by the Toba eruption is inescapable. These volcanic winters and the consequences of such apocalyptic change may only happen once